welcome back to my channel. I finally have this little heater, house heater here. It's about 36 by 20 inches, right? And let's see the measurements actually. So yeah, it's a 36 inches by 16 inches. I guess you can make it shorter, like about 12 or 13 inches. Kind of like narrow, and you don't need to make it that tall, but it's a mining rig, so it was 15 inch tall, about 14 and a half. You can make it also a little bit smaller. You don't need that space on that, probably reduce by 3-4 inches as well. So it is nice temperatures on the web GUI on all of these 7 miners. They've been running at 50% fans with under 55 degrees Celsius on the exhaust side sensors, and the just measure temperatures, measure noise for you. So for whole this setup is about what was it, 48 decibel. $45-44, so it looks like even lower than 48. It's about 45 decibels, and it is 650 watts of the wall, and at 120 volt plug. So let's take a look at components. We do have one single server PSU Hewlett Packard. I believe it is the Platinum version. And by the way, guys, I'm checking all my servers from GPU to get a better power consumption. I do check them on idle without connecting any cables. So this one on idle is only 6 watts, and so it makes about efficiency about 85% roughly. 85 to 90. I think it's a little better on 240 volts, but however, my fan's running at, so there's temperature sensors here on each side. So I have 4 fans on one side and 3 fans on the other side. This controller supports 2 temperature sensors, and so it's running at 870 RPM on the left side because it's a little bit warmer away from the door here and the sliding door, so I get a little bit of cooler air probably from that side, and then this side from the right is 720. It's pretty close, but this is 720 RPM. The left side is 870. The maximum RPM on these fans is 1400 RPM. Now, what's interesting is the at 1400 RPM, sorry about that, I have the wind speed controller, so we're gonna test this out too. Watch. So we're gonna have, we set at miles per hour here, the room temperature roughly about 74 degrees. Right, plus minus. So this heater, I don't use any other heat in the room, and let's take a look. So we are about 2.5 miles per hour wind on the exhaust side of these fans. It's about I believe about 5 miles per hour here on this side. Let's take a look. Of course, upside down, it's about 4.2 miles on intake wind, and about 2.5 miles per hour on the exhaust side. So now let's take a look. Let me put it there, just right here, so I can fix this and I don't have to hold it. All right, so hope you could see that. So now what we're gonna do, we're gonna change parameters here on the temperature, lower temperature. So I'm gonna set on my right side lower temperatures. I'm gonna drop to let's say 30 degrees minimum, and the high at 36. Okay, so right now it's 39 degrees, so obviously it's gonna go to the full blast on my right side. It's 1400 RPM. So let's take a look at 1400 RPM. We are about 4.3, 4.5 miles per hour on the exhaust. So that's the maximum fan speed, and it's still quiet. Now let's take a look on the wind here. Factor is about, I don't know if you guys can see this, about 7.5 miles per hour on intake, and about 4.5 roughly miles per hour on the exhaust. So it does lose some air pressure while it's going through this distance, of course. So, but regardless, let's take a look at the noise. When we set, let's set both sides actually on the, let's set this also at 30 degree low and 36 degree high. So now we're gonna be at the full blast. Okay, so we 1440 on the left side and almost 1400 on the right side. Let's take a look. So that's basically gonna probably bring temperatures down by a lot. Let's take a look at the power. So we did increase power to 658 watts. So we did add it almost 10 watts for a full blast, which I never use. And let's take a look at our noise. So we only increased by 5 decibel from 45 to 50 by going, basically by going on the full blast. So let's go and set it up to the lowest speed. And I'll show you guys the trick here, because at the lowest speed I'm still getting pretty good results. So let's set the lowest 38 here, high 43, low 38, height 45. Let's do 38, 40, 45, 40, 45. Okay, so both sides are 40, 45s. So it's running at 650 on the left, 650 RPM on the left side, and on the right side 530. So it's gonna drop a little bit, 620, 600 RPM. So that's around 600 RPM on the fan speeds. All these four fans and then 3 fans on this side at 520 RPM or 520, yeah, it's a little lower. Now, first let's take a look, how does it affect power consumption. So yeah, we dropped to 649 watts. This is incredible. And the pressure here, let's take a look at lowest. It actually can't even measure pressure, is it? So it can measure, so it's about 2.5 on intake, and it can't even register, go to, look at that, it can't register any air coming out because the fan speeds are the lowest. So it's about 2.5 miles per hour on intake, and then this device cannot measure lower, I guess, than a few miles per hour. Maybe that's what it is. Yeah. So anyways, this speed is just enough to cool down at 50% of the internal fans to be under 55 degrees Celsius, which is the normal temperatures. Now let's take a look and see if our temperatures changed on the actual device. So it went from 95 to around 98, which is not too bad. Pretty consistent. This one is the last one, is about 102. It's probably the warmest. What is the hottest one? Is 39 degree Celsius, but other than that, it's below 35, 36 degrees. So my guess is internal fans here I probably set to 40% because this was the coolest side, or maybe 30%. That's why it's getting a little bit warmer when internal fans also turn down. Now what else? On this setup we have basically a fan control, fan speed controller hooked up here to the power, 12 volt. Then we have all this Iceriver Ks0 PRO connected to 12 volts. Everything 12 volt directly, you could see from pcie, GPU, power cables. I have these adapters XT60 and it goes directly, all of them, to the Iceriver Ks PRO 12 volt system. So this 12 volt system allows me to save another roughly 15 watts if I don't connect the 19 volt step ups. Also on this side, let's take a look. We do have Ethernet switch, 8-port switch, and this powered up by also by this server PSU. So really I only have one power cable to the whole heater. So this whole heater, you could see, doesn't have any other cables, only one power coming in and Ethernet cable coming in. And it's basically hooks up from this switch all of these miners with the short 18-inch patch cables, Cat6, to the internet. So the whole entire system can work here of this setup. Also I have this Wi-Fi that is 3 watt, it's gonna consume 3 watt, and it's Wi-Fi to Ethernet adapter. So I can plug it in, maybe mount somewhere here on top. Just didn't figure it out if I wanna move this around the house and have this Ethernet connector available, so I can plug it in this side to my switch to this instead of hardwire to that. I could hook it up just there and plug it in. So it will add 3 watts to total consumption, which is going to go from 649 to 653 on the low speed and probably around 660 on the high speed fans, which I almost never run on the high speed. I set it up usually on the medium a little bit. I add a little bit higher temperatures. You could see my sensor went to 40 degrees and I'd like to keep them so they drop it to around 38. By the way, my sensors are at the exhaust holes there. It just goes right into the hottest spot there. Okay, so that's in the hottest spot inside. That's where the 40 degrees it's reached, but I can drop it to about 38, which makes them even cooler. And it's not really necessary, but this whole sink is warming up this room. That's about 200 square feet room pretty easily. And you can see, even with, I open doors a little bit, it's about 50 degrees outside. On inside, we're getting about 75 degrees. 75 degrees in the room temperature just by this heater. Really comfortable temperature, doesn't overheat the room, doesn't create any noise, adds a nice little heater. Let me know, guys, what you think about this heater. I know it's ugly design. This is just kind of a test. I guess you can get the nicer black frame to blend this whole system together, maybe even black power supply or something that is just gonna blend all together. This is just an extra power supply. I figured, like, if you go over 60%, this fans becomes a little noisier. On my other rig, which is regular K0 originals, this is 1, 2, 3, 4, 5, 6 K0s overclocked. 3 of them overclocked to 175. The other 3 didn't go that far. They go to 130 or 140, 140 and 150. I do use 19 volt step up on this system just because it didn't work, half of them didn't work on 12 volt. What else interesting? And I added second power supply, so there's two power supplies, so I can reduce the fan noise because the power consumption on this 740 watts only for 6 miners, and they do about total of 950 gigahash versus 1.4 terahash. So that's pretty much it for this video. Let me know, guys, what you think about it, and leave the comments below if you'd like to see any other testing. I did run them on the by the way, all of this was tested on the 19 volts, 12 volt and 24 volts, and I got slightly different results. On the only part is changing is the temperature and obviously power consumption because of the step-up transformers using a converter using additional 10%, I think, losing on the when it's converting power. So that's pretty much it for this video. Leave the comments down below, subscribe to my channel if you want to see more of this content. See you.